Okay, good afternoon. Well, good afternoon, discrete math students. It is about 1 o'clock in the afternoon, so for me, it's good afternoon. You could be watching this in the morning, in the evening, in the middle of the night. I don't know. What I want to do in this video is basically give you an example of the type of problem that you're going to be solving in your second Mathematica assignment. I've already communicated with some of you about your first Mathematica assignment. um, some of your Mathematica assignments are already graded, and I emailed you the results. If you haven't heard from me yet via an email, that's because I haven't graded your assignment yet. But don't worry, I'm going to grade it very soon, and I will do my best to get back to everyone and provide some feedback about the assignment within the next few days. So it is now July 12th. So hopefully, all of your Mathematica assignments will be graded by the 14th or 15th, and I will respond to you with your grade in an email. So I've emailed some of you already, and some of you I haven't reached yet because I'm just not done grading all the assignments. Okay, so let's talk about your second Mathematica assignment. Now, here's the situation. I'm going to show you how to solve a problem like this using Haskell, and you're going to figure out how to solve the problem using Mathematica. If I show you how to solve the problem using Mathematica, I'm basically just giving you the answer, and there's not much for you to do except copy my work. So that's kind of ridiculous, right? I mean, what are you learning except, how to copy and plagiarize? So I'm going to show you the general idea of how to do this in Haskell, and then give you some clues about how to do this in Mathematica, and then you're going to do something very similar in Mathematica. The exact numbers of your problem will be different, but basically it's going to be the same type of problem. Okay? So let's go to this website over here. Oh, you know what? Let me just delete this file right here. Okay. All right. So this is a Wikipedia article about the knapsack problem. You can see the address. You can see the URL or the website, the web address right over here. Okay. You could go to Wikipedia and look it up, but I have a feeling you're going to get way more information than you really need, and some of it could really confuse you pretty badly. So hopefully my explanation will, send you in the right direction. Okay, so you have a backpack or a knapsack, and the weight is 15 kilograms, right? It's 15 kilograms. And we're looking at 1, 2, 3, 4, 5 different boxes of materials, okay? So the green box has a weight of 12 kilograms and it's worth $4. The blue box has a weight of 2 kilograms and is worth $2. The tan box or brown box has a weight of 1 kilogram and is worth $1. The yellow box has a weight of 4 kilograms and is worth $10. And the grayish box has a weight of 1 kilogram, a weight of 1 kilogram and is worth $2. So the problem is I want to be able to fit as many of these boxes as possible into my backpack, but also make the maximum amount of money. Okay, so how are we going to do this? Well, first of all, let me open up a terminal window. Okay, so I'm going to be going back and forth for a few minutes between my terminal window and the that picture on the web page. So let me start Haskell, and remember, in Mathematica, it's pretty much the same idea, but obviously the names of the commands are different. But that's where you have to do your homework and figure some stuff out by yourself. I can't give you all the answers, especially since the course is online. With an online course, guys, you really have to take the initiative and do a lot of the work by yourself. Okay, so let's get started. Let's do the profits. Profits, let's see what I have here. $4, $2, $4, $2. I'm starting with the green box and going clockwise. $4, $2, $1. $10, $2. $10, $2. Those are my profits. And the weights going in the same order, okay? Going in the same order, that's really important. Actually, let me make this, hold on. Let me resize the window just for a moment. Okay. All right, just for a moment, let me resize that window. Okay, so the green box, okay, is a profit of $4. The blue box is a profit of $2. The brown box is a profit of $1. The yellow box is a profit of $10. The grayish box is a profit of $2. Okay. What are the weights? We have, starting with the green box, 12 kilograms, 2 kilograms, 1 kilogram, 4 kilograms, 1 kilogram. Okay, so let's make sure this is correct. And you'll be doing the same thing in Mathematica, right? I mean, it's not a big deal, except the notation is different, right? Okay, so the green box, let's see, green box, profit of $4, weight of 12 kilograms. Blue box, profit of $2, weight of 2 kilograms. Brown box, we have a profit of $1 and a weight of 1 kilogram. The yellow box, a profit of $10 and a weight of 4 kilograms. The grayish box, a profit of $2 and a weight of 1 kilogram. So that looks good. Okay? I'm going to minimize this because we really don't need that anymore. And let me expand this. Okay, and oh, 1 second. So that maximum, yeah, 15 kilograms. Okay, 15 kilograms is the maximum weight. So max weight of the knapsack is 15 kilograms. Let me just check to be sure. 15 kilograms. Okay. Okay, so we can figure out the solution to this problem. It's really not a big deal, but we need to do this in a very systematic way. So the first thing I'm going to do is I have to write a dot product function. Now, Mathematica has a dot product function for you that's built in. It's just called dot. It's just called dot. We have to write our own dot product function in Haskell, but that's really easy to do. That's really, really easy to do. So we're going to do that right now. Dot product, okay. I don't care. Well, actually, I'm going to write the type signature. So this is going to take a list of ints. Well, you know what? Hold on. Hold on 1 second. Before I do that, let me check something. Profits. Okay, so weights. Okay, so num A could be an int, an integer, a float, a double, All right, that should be okay. We really just want to work with integers right now, okay? So my dot product is going to take two int lists and it's going to return an int, right? So it doesn't matter, let's say, what the first argument is. If the second argument is the empty list, then we're going to have a result of 0, right? Similarly, if the first argument is the empty list, we ignore the second argument and we have 0. Dot product x x's, y y's. This notation means this is the first element of the list and these are all the other elements. This is the first element of the list and these are all my other elements, okay? And that's going to be equal to x times y plus the dot product of x's and y's. Okay, now let's see if that really works. So let's say, for example, I decide to take the first 4 boxes. So dot product 1, 1, 1, 0. I'm going to take the first 4 boxes. And what is that weight going to be? Weights? The answer is 19 kilograms. Let's see if that's true. 12 times 1 plus 2 times 1 plus 1 times 1 plus 4 times 1 plus 0 times 1 is equal to 19. So if I take the first 4 boxes and put them in my backpack is going to hold 19 kilograms, but there's a problem. What is the problem? The problem is that my backpack can only hold 15 kilograms. So obviously, that's going to be a very bad choice. That's not a feasible choice, is it? Okay, so let's try it again with a different combination. So dot product. How about if I just take the first 2 boxes? 1, 1, 0, 0, 0 weights. Okay, so if I take the first 2 boxes, that means that I'm putting 12 plus 2 or 14 kilograms into my 15 kilogram backpack. That's okay. That's a feasible solution. That's an acceptable solution. The profit is going to be 4 plus 2, which is 6. $6. Does that make sense? So dot product 1, 1, 0, 0, 0. And what is the profit? The profit is $6. 4 plus 2 is 6, right? So I take the first box, I take the second box, I do not take, the other 3 boxes, right? 0 times 2. So that means I'm making a profit of $6. Okay, but maybe I could make a better profit, right? Maybe I could make a better profit if I use a different combination of boxes. I hope you're starting to see what this problem is all about, okay? So how are we going to solve this problem? Well, first of all, we have to consider all of the combinations, all of the different combinations, and that's going to be very easy to do, all right? So there are many ways of doing this in Haskell. The way I'm going to do it is like this. And in Mathematica, this is unbelievably easy. You would use the Tuples command. Tuples, you would use the Tuples command to figure this out, okay? So what should I call it? Should I call it tuples? I'll call it tuples. In Mathematica, it's capital T. But capital letters are reserved for special things in Haskell, so I'm going to use a lowercase t, okay? Tuples, that's going to take an int. That's going to take a list, well, a list of any t value. And I'm just going to call it t. You can call it whatever you want to call it, actually. All right, and, sorry about that. Tuples 0. And it doesn't matter what that list is. If the integer value or integer argument is 0, I'm going to return my list, which simply means I'm getting a list of lists. If I return a list, that means I'm getting a list of lists. Now, if the integer is bigger than 0, okay, I have a list x's, then what I'm going to have is something that looks like this, okay? So, values, values are the numbers, the elements, I should say elements. They don't have to be numbers. They're the elements contained within my list, okay? And then I have my recursive call. I could call it recursive, I'll call it recursive f, recursive function. And that's going to be tuples k minus 1 x's. So this has the value of t, and this has the value now of t, and this has the value of a list of t's, okay? And then I'm going to return values cons onto my recursive, one second, recursive f, okay? So cons is how you take a value and you put it at the front of a list, okay? And we should be good. So we have here 5 boxes, 1, 2, 3, 4, 5. 5 boxes, 1, 2, 3, 4, 5, okay? And if we're not sure, we could do weights, profits, it should be the same. We have 5 boxes. So tuples 0, 1, oh, whoops, I almost forgot. 5 boxes. And these are going to be all the different combinations of zeros and ones, right? So for example, tuples 5, 0, 1. Okay, so 0, 0, 0, 0, 0 means I don't take any of the boxes, right? And then 1, 1, 1, 1, 1 means I'm going to take all of the boxes. Okay, and then I have every combination in between. So how many combinations do I have? Oh, wait a minute. Hold on one second. Okay. How many combinations do I have? 32. Why is the number 32? 2 to the power 5 is 32. Okay, I have 2 possibilities. 0 means I don't include the box in my backpack, and 1 means I do include the box in my backpack. So there are 2 options or 2 possibilities raised to the power of 5 because I have 5 boxes. Okay, so that should be clear. However, obviously some of these combinations are not going to work because remember that there is a weight restriction. I cannot put more than 15 kilograms of material into my backpack. The weight restriction is 15 kilograms, right? So I need to filter out. I need to filter out combinations that simply won't work. How am I going to do that? Okay, so my feasible, feasible means acceptable. Feasible solutions would be filter I could use any letter I want. Most math teachers just love the letter X. I don't care what letter you decide to use. Let me look at one thing here. So the weight, we have our weights. Okay. So the dot product of X with, or I could call it, you know, vector, I mean, call it whatever you want to call it. So the dot product of my vector and weights must be less than or equal to 15 kilograms. Okay. Tuples 501. So the dollar sign means that this computation is done separately from this computation. Okay, so what is that going to be? Feasible solutions. The length of feasible solutions is 23. So I went from 32 possible solutions to 23 possible solutions. Okay, hold on. This pen is going to fall on the floor here. So I went from 32 possible solutions to 23 possible solutions. What that means is that 9 of the original solutions were filtered out. Okay, they were filtered out because if you added up the weights, you know, the sum exceeded 15 kilograms, which is the maximum weight of the knapsack or the backpack for this particular problem. And remember, you can do all of this in Mathematica. You have to figure out how to do this in Mathematica. That's going to be your job. Okay? You need to figure that out in Mathematica. So, but you know, it's the same idea. You know, the names of the commands are different, but it's totally the same idea. All right? Now, how do we find the best solution? The best solution is the solution that gives me the greatest profits. Yes, you could use a for loop, but the problem is Haskell doesn't contain any for loops. It has something equivalent, which is called a fold. It's called a fold, which is very similar to a for loop, and Mathematica gives you a choice. In Mathematica, you could use a for loop or you could use a fold. Okay, the fold in Mathematica is just like the fold in Haskell. Okay, Haskell doesn't really have for loops, but it does have folds, and it has some other things you can use for looping and stuff like that. But Haskell doesn't have it doesn't have regular for loops like you would find in C or C++ or Java or Python. Okay, so how do we find that maximum amount of money? Well, or the maximum profit. Okay, so let's see. I'm going to call this show profits. And how should I do this? We're going to do a map. We're going to do a map, and again, I'm going to have this variable. I could call it, you know, vector, call it whatever you want to call it, you know, X or Y or Z or any give it any variable name that's meaningful for you. Okay, vector, if you want to call it a vector. And we're going to have, let's see, the dot product of the vector with profits, vector, and feasible, having a hard time typing today, feasible solutions. Okay, so let's print this out. Show profits. Okay, so let me see here. If I don't select any boxes, my profit is $0. Well, that's not much of a surprise, right? If I don't put anything into my backpack, then there's no money to be gained, there's no profit. If I choose only the last box, I've made $2, the second to the last box, $10, the last two boxes, $12. You see you get the idea. It looks to me, if I just use my eyes, if my eyes don't deceive me, it looks like this is the best solution right over here. Let me see. If my eyes don't deceive me, it looks like the best solution is right here. Okay, so I would ignore the first item or the first box, and I would take the last four, and that would give me a profit of $15. I believe that's correct. Obviously, if you're dealing with a lot of lists, hundreds and hundreds of lists, you're not going to print it all out and then try to figure it out visually, because that'll take you hours and hours or even days, and you could make a mistake, right? So the way to do this is to iterate through this entire list. Okay, we're going to use something called fold L1. The command in Haskell is fold L1. In Mathematica, it's just fold. And of course, in Mathematica, all function names begin with a capital F. So you want to look up fold. You want to look up fold. Capital F-O-L-D, fold. Okay, but in Haskell, we're going to use fold L1, which takes a function of two arguments. So we're going to have, let's see, what should I call it? Profit1, vector 1, profit2, vector 2. If profit1 is greater than profit2, if profit1 is greater than profit2, return profit1, vector 1, else return profit2, vector 2, and apply this fold to show profits. Oops. And, oh, fold L1. Okay, wait a minute. That's why I'm getting an error message. Sorry about that. Fold L1. There we go. So the answer is right here. Let me recompute that. Okay, my solution to problem is okay, the solution to the problem is this. I will make a profit of $15 right over here. I'm looking at the bottom of the screen. I will make a profit of $15 if I load the last 4 boxes into my backpack. So if I load the last 4 boxes into my backpack, I will get the maximum profit, which is $15. Now let's see if, does that make sense? So 2 kilograms plus 1 kilogram, that's 3, plus 4 is 7, and 7 plus 1 is 8. I have 8 kilograms of material in my backpack with 7 kilograms left over. And my profit is $2. $1, that's 3, plus 10 is 13, plus 2, it's $15 in profits. $15 in profits. And again, you can do all of this in Mathematica. Now, I'm not going to send you the exact problem that you're going to work on yet. I'm going to send that to you after I am done grading all of the first Mathematica assignments. And then once I'm done grading the first Mathematica assignments, I will send you, something like this. I will tell you, okay, you have a backpack. The maximum capacity is whatever, 20 kilograms or 30 or whatever, or 15 pounds or 20 pounds, 25 pounds, whatever. And I will tell you, these are the items that you want to put into your backpack. Okay, this is the weight of each item, and this is the amount of profit of each item. And you have to tell me, which items you're going to put into your backpack and what that maximum profit is going to be. You're going to do it in Mathematica, and you're going to use this as your guide. Now remember, this is Haskell. This is Haskell. This is not Mathematica, but you can use Mathematica to get exactly the same results. Obviously, the names of the commands are different, the syntax is different. So, in Mathematica, well, in Haskell, a list looks like this. 1, 2, 3, 4, 5. That's a list in Haskell. A list in Mathematica is going to look like this. 1, 2, 3, 4, 5, curly braces. Totally different, right? The syntax is different, but the logic is exactly the same. The logic is exactly the same, right? So your job is to figure out how to do this in Mathematica. And like I said, this is not your problem yet. I will email you the details of your problem after I am done grading all of the first Mathematica assignments. This is only an example. This is an example, so don't solve this problem and then email it to me, because if you do, I'm going to think to myself, what is wrong with this student? He or she does not know how to follow directions. You're not supposed to solve this problem. This is just an example for you to look at. This is just an example for you to look at. That's all. The problem that you're supposed to solve, I haven't even given it to you yet. I will email it to you when I am done grading the first Mathematica assignments. But this is to give you a general idea of what the procedure is for solving a typical knapsack problem. Okay? So, excuse me, I have a little bit of a sore throat today. Hopefully this has been instructive. You've learned a little bit about Haskell. You've learned a little bit about the knapsack problem. Okay, so hopefully this video has been instructive. I'm sure it's been a little bit confusing because I'm using, terminology that you haven't heard before. I'm doing stuff that you haven't seen before. I totally get it. I know it's a little bit confusing. But if you're not confused at all, if everything in this course is extremely easy for you, then you should be teaching the course, okay? If everything in this course is really easy, then why are you taking this course? So, sometimes a little confusion is a good thing. It means that you're struggling to learn a new idea, a new concept, okay? So sometimes a little confusion is good. Like they say at the gym, at the health club, no pain, no gain. And that's not just true of muscles. I think that's true of your mind as well. Okay? All right. Take care, everyone. Have a great day. Bye-bye.